All right, so on our main activity, we had a couple of buttons. Now, remind me, what is, for on next page button pressed, what is this view used for? And you could read the code below it if you want a reminder, but prove to me that you understand that concept. Go ahead. Well, this is where we figure out what page we're going to, right? So this is where we create the intent to go to the next screen, screen 2 or screen 3. But what is V going to actually be? Who is V? Go ahead.
It seems like it checks for button action.
Okay. Tell me more.
So
Something a little bit less parenthetical notation. What do you mean by button action?
Like anything that happens with buttons, it will check for that and then change its value.
What do you mean by check for that? Who is this guy? Simply, who will that guy be when this on next page button press gets called? Nope. Nope. Here's the questions we're asking. I'm asking if V is equal to page 2 button, if V is equal to page 3 button, and what's page 2 button and page 3 buttons? What are those guys? Cat, dog, or buttons from our scene. Those are buttons from the scene, right? We create a variable called page 2 button up here. He's a button. Create another variable, page 3 button. He's a button. In onCreate, we went ahead and set those guys to their values. What value did we set each one to? We set it equal to the button version of this.findViewById, r.id page 2 button. So on our screen, on our layout, we named our 2 buttons page 2 button and page 3 button, and now we've associated themselves, each of those buttons, with variables in here, so we have programmatic access to them. So that's MVC, right? Connecting those two together. So if I'm asking if V is equal to the page 2 button, what does that tell me that V must be? Okay, it is a variable. We're good with that. What kind of variable? Let's go back over here to activity main. Here's my 2 buttons, right? Both of these buttons have an on click, and both of them call the exact same function with their on click. So what is V? The answer is kind of like sitting right here in the, this tells you the answer, as does this line right here. V is the button that called this function. So whichever of our 2 buttons called this function, that's what V will be equal to. V will be a pointer to the button that called this guy. And what are we asking here? We're asking, is V equivalent to the button that we know of as being page 2 button? Is it the same button? Did the guy who called the function this time, is he this guy? Otherwise, is the guy who called the function this time equal to this guy? So when we have on-click action functions, this view that that guy is required to take as a parameter will be equal to, at runtime, whatever widget called that function. In this case, we've only worked with buttons for being the potential widgets. Make sense? So if we click on button 1, or I'm sorry, button 2, If I click on this button, as soon as I click, it's going to call the on next page button pressed, and it's going to pass in as the dude who called it the page 2 button's ID, or the pointer to page 2 button. If I click on page 3, it's going to call this exact same function, but that time through, he's going to pass himself in. So page 3 button will pass himself in as the button that called this. That way inside here, we can differentiate between which buttons happen to call this function. So that's a tool we can use for kind of using one function for multiple widgets. In this case, the only widgets we're using are buttons. Does that make sense? Does it actually make sense? Pretty sure I asked if it made sense last time. By the answers, it didn't seem to. All right, so we're always aware inside of these MVC functions. We are always aware who from our layout called that function. We can ask that question by looking at V. Now, many times we might not care. If we have one function per button, we know who called it. We don't have to look at V. We don't have to say, did button 1 call it? Well, button 1's the only button that's hooked up to this function, so therefore, yes, that's who called it. I don't have to check to see if V was equal to button 1. But if I were interested, in this case, I have one function playing double duty. It knows how to do different things based on which button was pressed. Now I have the ability to ask who clicked it. Okay? And that's something that translates over to iOS as well. This isn't something you need to memorize for Android. On the iOS side of things, when you create something called in iOS, these are something called IB actions. So interface builder action. And so this guy might be on next. Actually, it would be the way this function would be written in Swift would be, it would be a, actually, the way I was just writing it was Objective-C. Well, here, I'll show you both. Here's the Objective-C version. So IB action on next page button pressed. Something like that. Here's our sender, and sender is a view. Actually, this guy's a UI view. In Swift, this would be IB action on next page button pressed UI view sender. So this guy looks a little bit more Java-like, except what he returns is something called an IB action. In fact, actually what this guy does is he marks himself as being an IB action, which is how iOS does MVC. It exposes anything that's an IB action in code, exposes itself to the interface builder, the layout, so that we can then hook that up to a buttons event. Kind of like the on-click thing. Okay, but punchline here is that in iOS development, a IB action or a MVC function also becomes aware of who called it, if you are interested in that kind of information. Make sense? Okay, so we are creating an intent. So an intent gives us the ability to jump to another screen. It also gives us a lot of other abilities. It's our intent to do something. Right now, the only somethings we are doing is going to other screens. All right, so we intend to go to another screen starting from this current context. So this guy right here holds all the information about where we currently are. That's part of what an intent requires. So if I intend to throw a ball to Charlie, okay, I'm throwing it from my current state right here, and that might have something to do with I apply force to the ball in this direction, that it flies towards Charlie, whereas if I throw the ball this way, Charlie's going to have to do one of those diving things, right? Over that row. You're going to go high because he's a little bit taller. All right, so in any case, having the context of where we're starting from is just part of the syntax for it. Leave it at that for now. And then where are we going? We want to go to the class associated with screen 2. So that will create an instance of this activity, screen 2 activity, which will then call his onCreate. And what does his onCreate do? His onCreate sets his content view equal to the layout associated with screen 2. So that's how we follow through with this. All right, so when you first get into an activity and you look at his onCreate, this tells you how this guy is being set up. Okay. Similarly, if we go back to main activity, after we create our intent, we're kind of preparing. Then we actually say, start the activity associated with the intent we just created. That's how we actually do it. Okay, I'm preparing to throw the ball to Charlie. Now I actually throw the ball to Charlie. Okay, left-handed, that's why it was. All right, so in any case, otherwise, if it was the other button, we're going to intend to go to that other class, and we'll start that activity. Okay? Now, last time we looked at how to get information from screen 1 to screen 2 in our activities. All right, we talked about two different ways of doing it. If I want to get information from right now I'm in screen 1, I'm in my main activity, and I want to send some data to my screen 2. So for example, maybe I want to pass the username or the ID associated with the current user that's logged in, or some other piece of information. I need to get information from screen 1 to screen 2. All right. What are my couple of options that we talked about last time for getting data from screen 1 to screen 2? Okay, we can use it. Tell me about singletons. Okay, so singleton is a design pattern, right? It's actually a very popular design pattern. It's a really convenient design pattern. So convenient we have to be a little bit careful how we use it. And I'll review that again in a few minutes. But a singleton is one of the design patterns that says it's a good idea when you have data to share between more than one screen, in our example here, to store all that information in one place. And I use the example probably of sharing a car with all of us. We put the keys in one drawer, something like that. All right, so one way we can get stuff over there is through a singleton. So for example, what did we do? We have this singleton we created in here. Is this guy what kind of animal is this guy? He's inside of a class. What are the possible answers to that question? What things make up classes? We have 3 things that make up a class. What are those 3 things? Methods, constructors, and fields. Okay? Which of those 3 is this guy? Right off the bat, we know he's not a what? He's not a constructor. How do we know? Doesn't have the same name as the class. And whatever, that's good enough. It doesn't have the same name as the class. Okay, so the options that are left over is method or field. Which of these guys is he? He's a field. How do you know it's a field? So you answered this last class, and you had a more right answer last class, and it was a funny answer last class because you referenced his funny response. Yeah, no parenthetical notation. This guy doesn't have parentheses on the end of it. We don't have something like this. So since we don't see parentheses, there's no parameter list, therefore it's not a function thingy. So definitely not a constructor because it doesn't match the name, even though constructors do have the parenthetical notation. But he's also not a method because he doesn't have the parentheses. So the only guy left is field. So this guy is a field, which is just a variable associated with a class. All right, is this a class field or an instance field? Class field, how do you know? Static, good. Okay, so this is where we're defining this guy, and he is a field named myname of type string, and we've made him static, which means that he is a class field. Now, when something is a class field, how do we call it? Using the name of the class in which the field was defined. If it was a class method, we call it using the name of the class in which the method was defined. So in this case, we'll reference this guy as core.myname. All right, so here in main activity, when I go to page 2, right before I start that activity, I can say something like core.myname is equal to Mike. Oh. Okay, and now that is stored, we can almost think of it as in the cloud. Okay, except it's not outside the building, it's just in another class here. Okay, we've kind of stored that in our singleton. So in this case, core is the singleton that right now knows how to store one piece of information for us. Okay, so when I go to screen 2, I'm printing out the value of myname from core. So I just passed in, well, I didn't pass it to this guy. I set it there, then this guy reads it from here. So we put it in the drawer. So I'll go to page 2, and we print out myname, and that is going to be back in here in Android Monitor. There's myname. Okay, so that's one way we can get stuff to between 2 different activities. What's another way we can get things through 2 different activities? I have it currently commented out on the current screen that you see on the giant screen, medium-sized screen. Good. Okay. Specifically, we have this thing called extras, right? So intents come with their own luggage. All right, if we look back at main activity, rather than sending our name this way, we can say I.put extra my name, Mike. Okay, so an intent comes with a luggage compartment. So we can pack in our luggage name value pairs. So in this case, I'm saying I'm going to have a variable name, my name, and I'm going to set it equal to Mike. And that's going to be part of the intent. And then over here in screen2.java, rather than printing out core.myname, I'll go ahead and get the intent associated with this activity. That is the dude who got me here. I'll grab the intent. Then I'm going to get the string extra from this guy associated with the variable name myname. I happen to know that myname holds a string, so I can say get string extra. There is a version called get extra that gives you a generic object that you can then cast it to what you need it to be. But I know I stored a string inside of myname, so I'll say get string extra, telling it the variable name I want it to look for in my luggage. All right, we'll then extract that and throw it inside this variable called the name, and then I'll go ahead and print out the name. Make sense? Go ahead and hit play here. I'll go to page 2. We see here's our name, but this guy is, so it's the same name, but this was actually printed out by extracting it from our intent, not using the singleton version of this. You want to see the proof there. we can come, well, we're not even storing it inside of core. But here I can just change this to Dave as we pack it into the extras. And there we have Dave. Okay, so a couple different ways to get information between our two scenes. Which do you like better? You like the singleton because it's convenient, right? Just directly accessing the variable. Over here in main activity, we say core.myname equals Mike. We set it. Over here in screen 2, we say core.myname. We get it. Nice and convenient. So we might be tempted to use singletons for everything, right? In a large application, though, what you might end up happening is you might have this singleton that has just a bunch of stuff in it. Okay, there's tons and tons and tons of things. Let me show you an example. Let's see. Do I have a good example I can open up? I think so. All right, so here's a larger project. These are all source code files. And I'll find my singleton in. So here's a singleton I had in here called iplur core. I'll double click on this. Now, in retrospect, perfect. This is probably a singleton that was overused. You know, it started off as being one thing and then became kind of somewhat of a mess. And so I'm going to show you a bad example. But you'll see what could happen with this for a convenience reason. Is getting ready to launch Xcode, which is equivalent to Android Studio. This is where you would go to write iOS stuff, Apple stuff. Okay, so here is this file. So this is a singleton. Notice it has all these static variables. It has static functions. So a lot of crap in here. And what you'll notice is I actually have variables sprinkled throughout here trying to organize them. So like this is a variable associated with their one of their profile screens. Here's a bunch of variables associated with a manage inventory screen. So on and so forth. Here's some variables related to its trade screen. So we might say that this singleton is a little bit out of hand. Make sense? This would be a larger application. But point is we want to be somewhat good stewards of our singletons, because one thing is when we're writing relatively small applications like this, we might be tempted to just put everything inside of a singleton. Who cares if there's 5 or 6 variables up there? We can juggle 5 or 6 variables, not the end of the world. But in real practice, we want to really think about what do I put in the singleton and what don't I put in the singleton. So we really kind of need a rule of thumb. So rule of thumb might be use a singleton when a piece of data needs to be shared between more than 2 screens. Use put extra when a piece of data needs to be shared between 1 or 2 screens. And the real kind of almost tie goes to the runner type thing is when you're dealing with 2 screens. You know, it's if you have 10 pieces of information you need to share across those 2 screens, you can clog up your singleton with 10 pieces of information, or you can write the same code twice by putting 10 things inside of extras, putting 10 things inside of extras in 2 separate places. Okay, now this is related to a concept that you'll talk about in software engineering, but we'll talk about it here, called coupling. And coupling is the concept that let's just talk about it in terms of Android right now, but this goes between all sorts of, so the concept that one class is reliant on another class. Replace class with activity, replace class with view controller, whatever you want to do. Okay, so the idea is that, you know, we have a goal of minimizing coupling. That is to say, we want to have as few things in our program that are dependent on other things in our program. So if we decide to change something here, we don't have to go rewire up 50 things in other places. Okay, we can just change it here because this guy was standalone. He didn't rely on anybody outside of himself. Now, sometimes that's not possible, especially when we consider Android applications where we have things going from screen to screen to screen to screen. There's going to very likely be data that gets passed between multiple screens. Make sense? All right, so that's not the end of the world, but we do want to try to minimize coupling, and we want to be aware when we are saying that 2 screens are reliant on each other. So right here, we go back into our code here. When I put the extra in here into this intent, what I'm doing now is I'm making screen 2 reliant on something that came from screen 1, or main activity in this case. Now, on the flip side, if I go down here and I say core.myname is equal to, we'll make this one Mike. Is screen 3 still reliant on something that I've done in main activity? Or is screen 3 reliant on the existence of core? Does anything say that I absolutely 100% ever have to set this variable? I'm allowed to just not set that variable. Might not be the best idea. You might want to have maybe a default value in here. Maybe it's initially you can just have it as the empty string, or maybe you do it n/a, something like that, you know, whatever the default value is. So now if I try to grab my name, it'll work. When I'm in screen 2, or screen 3, that was when I'm in screen 3, and I ask core.myname, I'm going to get the value of core.myname. And if I never set it in main activity, if I decide or forget to do that, my screen 3 can still come in here and he can still say system.out.println core.myname. And just for the sake of argument here, let me default this to n/a, so there's something that'll print out. So what I'll do inside of main activity is I will forget to set it. So right now that's commented out. I'll then launch my page 3 activity. Page 3, screen 3, will do his normal launch stuff, associate the activity underscore screen3 layout with this guy, and then he'll try to print out the current value of core.myname. And we're going to see, what value should I see there? NA. I'll see NA because I never actually set it. It was just the default value from when I originally created that singleton. So there's my page 3. There's my row. I did hit page 3, didn't I? Oh, on page 3? Oh, I think main activity. No? Oh, at the top. Oh, thank you. Yeah, don't do this. I was globally setting it, so I was trying to forget to set it, but I just set it in the wrong place. Good, I was testing you. You passed. All right, so now I should be able to click it. Go to page 3, and we have our NA. So in that example, page 3 or screen 3 is reliant on the existence of core. He's hoping that main activity sets that value, but he's not reliant on main activity in order for him to function. He might be reliant on it in order to function correctly, but he's not reliant on it being able to function. So this idea of coupling is a fairly loose term, which is whatever. Fairly loose term. It really is just talking about the reliance of objects on each other. And you want to have as many things be able to stand on their own as possible. Now, what's the alternative? If we think about it a little bit more advanced application, we might say, let's say that you take a random iPhone app or a random Android app. A lot of them you log into, right? So you log into the app, now you're in there. And let's say there's 3 screens in the app and you are on screen 1 and at the top it puts in your username. Okay, chances are it got your username from the authentication process, so it passed the username and password up to whoever you're authenticating with, Google or something like that. And it said, yes, you're good. You gave me the right username and password. Here is the object associated with this account. Here's the username. Okay. So now you have that username on screen 1. You're going to go ahead and print out keep the username in a label or something like that at the top. Well, then I click a button. I go to screen 2. Well, let's say I want screen 2 to also show that the current user logged in as whatever that username was. Well, I can either pass it to that guy because I already have that information, or if I want those screens to really be independent of each other, I could choose on that second screen to go ahead and re-authenticate, having to collect another username and password from the user to re-authenticate, grab the username, bring it in there so you have it. Does that sound very efficient? How many of you would like an app if you had to re-log in on every screen? How many of you ever experienced that? And there's some apps that kind of have that. Steam is not actually an app, they're a website. If you're on Steam's developer portal for managing an application you've uploaded to Steam to sell, depending on whether you're looking at the financial stuff or managing your app, it's the same partners.steampowered.com site, but you have to log in a second time. It's completely dumb. It should not work that way, but it does. So that's the punchline. So that really doesn't make sense. It would make more sense for us to say, just bite the bullet and say, okay, well, at the very least, these 2 screens are reliant on, they both need to know the username. So I can request the username multiple times by hitting the server up there, and that's not very efficient and inconveniencing my end user. Or I can add some coupling into my application and say, all right, I'm going to create a singleton. Now, that would be a good example for using a singleton. If you have 10 screens in your application and each one needs access to the username, for example, singleton's perfect. You have a singleton, you throw the username up there, and now those 10 screens can all conveniently grab the username without you having to explicitly pass that information to each of those 10 screens. They can all just grab whatever the current logged in user is from the singleton. Perfect example of a singleton. Go ahead.
So part of me is wondering, as far as pass by value and pass by address, is there a difference between get event and a singleton? So like if I pass the data from one activity to another versus storing it as singleton and reading from that singleton, is there a difference?
I see what you're asking. It's actually a good question. I'm going to guess an answer and then let's test it. I believe, well, I think you're going to have a pointer. That's actually a quite insightful question. I believe you're going to have a pointer. So I think if we pass an object to the second screen and then we change that object, I believe we'll have it will be changed back in the original screen. So let's go ahead and we're going to say else if v is equal to actually we need to give ourselves let's give ourselves a third button, fourth button, third button, and we'll call this guy page 4. So it's going to be a page 4 button. And this guy will say, go to page 4. Okay, and then we're going to go ahead and we're going to need another activity. Call this screen 4. So we're going to new activity. Create an empty activity. Screen 4. All right, this guy looks like that. I'm not even going to put anything on screen. Well, actually, I'm gonna grab something from screen 4. I mean, first of all, if we put it in the singleton, 100% we're changing the same value. So singleton is passed by address. We're not even passing it. It's just there. Not only we're not using 2 different variable names to access it. It is the one variable name. So really, we're interested in put extras. So I'm going to go ahead and inside of main activity, I'm going to give myself another button. So we'll give myself a page 4 button. All right, then we'll go ahead and get that button equal. So this dot page 4 button is equal to the button version of this dot find view by ID r dot ID dot page 4 button. All right, so now we've connected up that button. And then down here in our button pressed, we'll say else if v is equal to this dot page 4 button, we're going to go ahead and we're going to create an instance of an object. So let's just give ourselves a sample object to pass along. So I'm going to create a new Java class. We'll call this guy my object. And inside of this class, we'll go ahead and we're going to create a private name, or private string name. And then we'll have a public my object. Whatever the name was passed in. And let's give ourselves a setter and getter for this guy. So we'll generate getter and setter for our name. So we can get the name and we can set the name, because what we're going to do is we're going to originally build the object with the name Mike. Then over in our next activity, we will print the object with our, we'll change the object with, maybe change the name to Dave. Then when we come back to the screen, we're going to display the object again and see if it's changed to Dave, which I think it will, or if it's going to revert to the old value, which is Mike, because the thing was passed by value. Okay. And then what I'm going to do at the same time here, just so we can introduce a new thing, is I'm going to throw another function in here. Well, here, let me show you this first. Pages per hour was estimating how big the Pendley assignment should be. Okay, so let's see. We're going to do a Android activity lifecycle. So this shows the different points of time we can access our activity. So we've already seen on create. All right. So we have on create, we have on start, we have on resume. So on resume is something when the activity comes back. All right. So when we go to the next screen and then we hit the back button, on resume will get called. So on create gets called one time, exactly one time ever. On resume, we'll get, let's see, user navigates to the activity. We'll have to see. Oh, user returns to the activity. I think it'll be on resume. So we'll have to see if it's on resume or on restart, which of the two happens when you hit the back button. So this is another point in time when we can decide we want to do something logic-based with our app. So I'm going to create the function here on resume. So on restart is our activity there. That's a fragment activity. So it looks like on restart is the actual one that we're going to use. And let's just test this real quick. Just print out restarted. Let's make sure that guy gets called every single time we come back to that screen. So I'll go to page 2, whatever, go back. Here's restarted. Let's go to page 3, go back. Did I get another? Here's another restarted. Page 3, go back, another restarted. So that function's getting called every single time we return to that page, that the previous activity is restarting. Okay? So what we'll do is we're going to create an instance of our variable up here. So I have a my object. So inside of main activity, I'll go ahead and I'll create a private my object called obj. And then in onCreate here, I'll go ahead and say this dot obj is equal to a new my object, and I pass it a name, so I'll pass it Mike. All right, so that guy looks that way to begin with. All right, and then on restart, I'm going to go ahead and print out this dot obj dot get name. So let's just make sure it's printing out Mike every single time to prove that our object is working. All right, so I'm just storing a name. I haven't actually passed this object to another screen yet. Let's just make sure every time I come back, it prints out Mike. Page 2, go back. There's my Mike. Page 3, go back. There's Mike. Okay, so that's working. So now what we want to do is we want to go ahead and we want to pass my object to screen 4 as an extra. Retrieve it inside of screen 4, change the name to something else. Then go back and see if that name was permanently changed. That'll tell us whether it was passed by address or passed by reference. Now, one thing we can do here to prove it, to make a pretty good guess, well, to make an exact guess, is I'm going to go ahead and say system.out.println this.obj. What should print out here when I print out my object? Memory address. What did we not write in my object that would have made it be something other than my address, than a memory address? ToString. Yeah, we didn't write ToString. So ToString is the actual function that println calls on an object that an object is guaranteed to have, because that function came from the generic object. Okay? Are you missing a bunch of people? Somebody want to donate a piece of paper? Pass it around and write your name on the piece of paper. Quiz, free quiz. So if you showed up to class today, you get 100 on a quiz. Just, well, you only need one piece of paper. Just put quiz on the top of it, write your name, and make sure everybody puts their name on it. I assume everybody wants a free 100 on a quiz. You'll take it? All right. What? Yeah, that's why I'm doing it. that's why I'm doing it. Huh? Yeah, I'm sure they don't want the quiz, but they're not going to be happy when they see they had one. Okay. But at least all the important people benefit from it, right? Okay, so we don't have that ToString method in here, therefore it's going to print out that memory address thingy and make sure I can read your name. I can, well, I think we don't have any closed names, so I'll figure it out. I don't have to actually be able to read it. So we didn't write ToString, so if we come in here, it's going to print out the crazy memory address thing. So let's just prove that real quick, that we get a crazy looking memory address. And then what I want to do is I'll add it to my extras, get us to screen 4. I'm going to print out the memory address there. If they match, then we're going to have real good confidence that we're going to be changing that same value. If they don't match, that means we got a clone. We got a duplicate of it. So I'm actually testing the reason why before I actually just test the result. Lets us further that idea of really understanding what's happening under the hood. Okay, so we have the memory address there. And then I'll go to page 4 here, and I'll go ahead and I'll say, I'll create my intent. I'll just type it again. Intent I is equal to a new intent starting from this and going to screen4.class. Okay, and then I'm going to say intent put extra. And the extra I'm going to call it obj. I'm going to put this dot obj. Ooh, can I not put, oh, thanks. We may have answered our own question here. Can I not put a generic object? Yeah, so we'll need to make something what's called serializable in order to make it work. All right, so we can actually, well, this lets us introduce some other things too. Okay, so the extra system knows how to attach any of our primitive types as well as like array types of our primitive types, but it actually does not know how to attach a generic object. Okay, and why is that? Because an object needs to be something called serializable. So serializable is something called, it's something of type interface. The keynote update, oh, can I not? Oh, there's no option just to keep going? Oh, that's, okay. So while I'm updating that, I'll mention it out loud. Let me just get it clicked. Okay, so an interface is similar to objects, and this is actually good we're running into it now because we had a couple of the Acuity guys who graduated from here and now work at Acuity who have mentioned that they wish they had more exposure to interfaces. I usually introduce it at some point, but they wanted to see it more. So an interface is something similar to a class. Didn't this happen last time? It doesn't index it. Okay. So it's something similar to a class, but does not actually implement the logic of it. Instead, it says that anybody who implements this something of this interface must write these functions. All right. So let's just put that in our slides here. An interface. So this is like a class, but without an implementation. So it really just lists fields and function names that must exist. So this lists fields and function names that classes that choose to implement this interface must implement in order to successfully use the interface. So we can think about this kind of in real life. So let's take an Xbox, for example. There are third-party controllers for Xbox, right? So Microsoft makes the Xbox controller that comes with the Xbox. And you go and it comes with the system. You can buy other ones like that. But let's say if you're a gamer or something, and there's like a special controller that's made for comfort or has some auto fire buttons, whatever. You might want to buy that third-party thing. Now, that third-party Xbox controller needs to be compatible with that Xbox, right? So the Xbox has this interface. So they say, here are the 8 things, for example, that the controller must be able to do to properly work with the Xbox. Make sense? So when that third-party company made that controller, they had to implement functions for those 8 things so that they can talk to the Xbox accurately. What they do on the other side of those 8 things, like for rapid-fire buttons, things like that, they can do in their own hardware and then turn those guys into one of those 8 functions, maybe calling the function like says, A button pressed a zillion times. You call it over and over and over again, something like that. All right, but that controller needed to implement those 8 functions that the Xbox says. In order to work with an Xbox, your controller has to have these functions. Make sense? That's an interface. Microsoft, though, did not create that controller. They didn't implement it. They just said, look, you want to work with our stuff, you need this interface. That makes sense? So that's how interfaces work in Java. This is a Java thing, not an Android thing. Okay, and most of our modern languages have interfaces. C# has them, things like that. So, for instance, here in our Android app, in put extras, we have a whole bunch of these. We can do a Boolean array, a Boolean value, blah, blah, blah. And then we get down to this thing called serializable. We also have a couple of things called parsable. So anytime, this is more of a naming convention thing, anytime you see an ABLE, an UBL at the end of something, pretty good guess that's an interface. So naming convention usually ends in UBL. Not required, just you see something that says somethingable, it's probably an interface. So let's go and look at the documentation, look at serializable. So your question opened up a big can of worms, but it was good. It's actually good stuff that we need to introduce anyways. So do I have the Java app? I do. Let's see if it's in java.lang. Here are the interfaces that come with java.lang. Serializable is not one of them. So let me go to all classes. Actually, I want to do all, can I do all interfaces? That is unfortunate. So I need to scroll down a bunch. No. It's a race. Oh, java.io. Well, I'm just about there anyways. So in the event that, passed it actually. Here's serializable. So I just did all classes and it, I had to search through there to find it. Click on that and there it shows me it's in java.io. So we will need to import java.io in order to make this guy serializable. But let's see what serializable means. So we're going to come down here. It doesn't actually make us write any methods. Well, that's actually convenient.
You do have to implement those methods to accept the serializable, but not to.
Right, yeah, not to create it. So, because something that is serializable, it should give you, let me just show you an example here. So I'll go to runnable. Runnable is something that's part of how you do threads, multi-threading in Java. And runnable requires that you create a public void run method. And you'll see how it shows it in here. So we have a single method summary called run that we have to write. So if you're going to make something runnable, you have to write that guy. So with that in mind, I believe we should be able to go into our class here, go to my object, and we're going to say that this guy we need to import. Actually, it'll probably do it for us. So we're going to say implements serializable, and it went ahead and imported java.io. All right, we won't do anything else in there. And it's not screaming at us. If we had forgotten to implement something, it would have yelled at us right now. Now I'll go back to main activity. I'll do put extra, and we're going to put in obj, and we're going to put in this dot obj. Okay, and he's happy with that guy now because that guy is a serializable object. Okay. Now let's go and look at screen 4 and see how we have to grab that guy. See if we're going to have to unpack it or if it'll unpack it for us. Okay, so in scene 4 here, we're going to go ahead and say my object obj is equal to this dot get intent dot get serializable extra. And what does that guy return? He returns a serializable. Okay, I think we're going to be okay there. obj. And we're going to say this guy is going to be actually a my object. So when we get the serializable, it's going to, so this is going to be that function that implemented those 3 extra fancy things. So we'll go ahead and squeeze it out. It's going to come out as a generic serializable. We'll convert it to our my object, which we know is serializable. We'll put it inside of this. I'm going to go ahead and print it here. And I'm going to explain this through pictures here in a few minutes, because this is actually doing some relatively complex things, even though we didn't have to write most of them. So we're going to do println. I'm going to print out obj. And let's just see if we get the same memory address first. Okay. So I'm printing out the memory address after we received it on our receiving end on screen 4. I am printing out the memory address when we first created it here in main activity. Right here. So those guys should match. Now I need to go make sure I've set up my screen 4 button, page 4 button to go to the to call my function here. This on next page button pressed. We've already put in our else if v is equal to page 4 button, but and I've packaged that object up with that. But I need to make sure in my activity main screen I have my scene 4 buttons on click set to the right thing, and I do, because I copied it from the other one. So let's see if we get the same memory addresses on both. All right, so this is our original screen, and I should have a funky memory address somewhere in here. Here it is. Oh, that's so D92 F0D4. 0D4 is probably going to be enough. All right, so now let's click on scene 4. Did not actually take me there. It's probably going to be this thing. Click on that, hit the drop down. I need to click that guy for no good reason other than the copy must not actually make it set. Oh, hold on. I don't think I actually started my intent. Main activity, I did not. This dot start activity, I need to actually tell it to start that intent. Okay, so starting address is 0D4. Go to page 4. We received it. Yeah, so pretty good guess this is not going to be passed by, well, I think it's actually more than a guess. We are working with a different object. All right, so if I come in here in screen 4, too many classes, screen 4, and I go ahead and say obj.setName to Dave, and then we do system.out.println obj.getName, should be Dave there. Then when we go back to our main activity, and I go on restart, I'm already printing out the name. So this guy should print back out Mike after we've done that, because we are not changing the same object. So we got a, let me get this guy. So initially we had our, well, doesn't matter. We're going to see it on the way back. It said Mike up above. Go to page 4. Now we should see Dave down here. Here's Dave. Then we're going to go back, and we see Mike. Pass by value is the answer to your question. But very interesting question, and actually a very useful piece of information, because we might want to pass objects between our two scenes. And now we've just proven to ourselves that if I want to pass an object from scene 1 to scene 2, I need to make it serializable, which I'll draw a picture here in a second. But that was easy. We just put implement serializable, and then it did the magic for us. No problem. All right. But I then by putting it as an extra, I am now taking on the understanding that that guy is not going to have global change. I am giving my destination a copy of this object. How would you do it if you want to actually be able to change the object? If I don't want to work with a copy, I want to work with the actual same memory location object. How would you have to do it now? Keep it in the singleton. Yeah, singleton will allow me to do that. So now I can go throw it in a singleton, change the object itself, and then come back and I'm working with the identical object, not just not just the same memory address, but it's the same variable. So let me show you a quick picture here. The scoop. So we have our main activity. All right. And then we have this intent thing. And intents are obviously yellow. And with that intent, we have some extras. And what we did is we had our my object, which is red. Okay, and my object was something that implemented serializable. Okay, which means that I am allowed to add one of these guys to my extras. Okay, so really in the middle here we had extras. So any of our specialty objects, things that are outside of strings or any of our primitive types, if we're going to make our own object we want to be able to pass, we have to make that object serializable, which Java's done all the heavy lifting for us. They know how to serialize an object and unserialize an object, which is actually called marshalling. So you serialize the object on the way out, you marshal the serialized version of the object on the way in. We didn't have to write either of those sides. We just had to mark our object as being serializable so that Java could do the magic for us. Okay? So that's us implementing an interface there. So when we did that, what ended up happening is this guy became a copy. He was not passed by address. Make sense? So he became a copy. So when we get over here to our screen 2, I'll just finish up here real quick. Our screen 4, sorry. Screen 4, and we receive from our intent our serialized dude here. This was not the original. He was a copy. We can make any changes we want here. When this guy dies and we come back here, we have our original that lived globally inside of main activity. That was our original. This guy has not been touched. Make sense? All right, so for your homework, just to get back into the swing of things, go ahead and create a application that has 2 screens, and pick your poison. You can send a string, you can send an int, I don't care what you send. Okay? But send through a singleton a value. Let's just pick a string name. Send the name through a singleton to one of the screens and show it inside of a text view, a label. Send through extras to the other screen and show inside the text view a label. Okay? So send Mike through a singleton, show Mike in the label, show Dave through extras, show Dave in the end. So practice sending things to the 2 different ways. Make sense? All right. I will see everybody on Thursday. Don't forget today's student, faculty, staff Bible study. God and Grub. You get free lunch. Go to the cafeteria. Just walk in, sign the sheet. You get free lunch. Grab your food. Take your tray down to the terrace room. I'll be there.